Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Every week we do a topic on Python or machine learning. Sometimes we do them online and sometimes we do them in person at Brisbane Business Hub. And the next one in person will be on the 14th of June. So tonight we're online and we're going to be looking at using the rabbitmq AMQP broker to send messages between Python programs, and we're also going to be using Docker as a way of running rabbitmq, and so we'll learn a bit about Docker as well. Now this is a live session, so you can ask questions. I will be listening on Slack. I'm already getting some questions coming through from Leo, so that's great, and we'll see when we get to that part if we can get it working for him. So it'll be in the Learning to Code channel in Beginners Python Slack channel, and you can there's instructions on how to get an invitation to that channel in below the YouTube or in the Meetup description. I'll also be listening to the YouTube chat, if I can find it. So there's the YouTube chat, so if you send messages there, I'll also pick them up, so that's good. Alright, you can also tell me if there's any problems with audio or visual while I'm streaming. My chat keeps disappearing. Alright, that's got it. Okay, so tonight we're going to be using some code that I've put up on GitHub. So it's really just some instructions and we're just going to walk through them. So if you click on the link will be below the YouTube video. It'll be this one over to GitHub, our BPML sessions, and there you can see all our past sessions, well, all the ones that I do, and tonight's number 183. So if we bring that one up, here's the link. And so we're going to have to use Docker. Now hopefully you've got Docker installed, because that will take a while. I've just had to install it on this computer here. It's a Windows 10 computer, and yeah, it took me a while to get it going, but I had this link here in. It suggests other links when you're doing it, but this one actually looks like the best one, so that's the one to go to and follow the steps through in that, and that got it working for Windows Subsystem for Linux too, which you need to get it running for Docker. Then once you've got that installed, install Docker Desktop, I recommend, which is free for personal use, unless you're doing it for commercial use in a company with 250 employees or more that has $10 million in annual revenue or more. All right. And I've given you some references here if you want to look up any of the things that we've done. Okay, so the first thing is just to check that our Docker is working. So we can do a Docker run hello world. I'll do that just in a command line prompt. So this should work on Mac or PC, Windows or Linux. On Mac or Linux you may need to do sudo in front of this, but if you type in world, the first thing you need to do before you run this is make sure you've got Docker Desktop running. So I've fired up Docker Desktop and it's currently saying there's nothing running. I'm in containers here, it's showing no containers. In images, I've got a couple of images. You won't have any yet, but as you do a couple of tasks you'll get some images. So what we'll see what happens if we run Docker run hello world. The first thing it does is creates a container from an image, so it looks to see if it's got an image, and if it does, it creates a container. So it looks, there's the image hello world, so it used that one and it created this container. We didn't give the container a name, so it's made up a name. I've got mine been called Youthful Williamson. Yours will get another name. And the status is exited, and all the hello world does is print this thing saying, yep, you've got it all working. Here's some more things you can try. And then it quits. So what Docker is doing, it's creating these containers, and containers are like virtual machines. So if you've used virtual machines, for example, on Amazon, EC2 host, or you've DigitalOcean, you've had a Droplet there, they're virtual machines, or on your own computer, you've used VirtualBox, create virtual machines. So containers are like that, but they're a lot more streamlined. So they, rather than create a full virtual machine, they borrow parts of the operating system that are on the computer that you're on. And that's why you need to, they're often Linux based. In fact, all the ones I've seen are Linux based, and they, so it's really good to have Linux running on your computer at the same time as you're running the container. And that's why we need WSL, which is Windows Subsystem for Linux, to running on your Windows computer if you're actually on a Windows computer, so that then Docker will work. All right. Now we've finished with this one now, so I can just delete it out of containers. And really, you don't ever store information in containers that you want to keep, because they are designed to just be thrown away. If you do want to keep data, you link the container to what's called a volume. We're not doing that yet. And then the volume can exist on your computer, and so the data that you're trying to save will be saved on your computer, even if you delete the container. And the images there, that's just a cache. So it's downloaded this hello world, and so it means it can create new containers based on the hello world image very, very quickly. All right. Any questions so far? Okay, now we're going to try to run a Python program here. So what I'm going to do this in PyCharm. You can just keep using command prompt like I did here, but I'll just, I think it's going to be easier if I use PyCharm for this. And we'll create a new project, and I'll just call it ppml 183, and that's just going to be in my home directory, and it's going to create a virtual environment, which is a fantastic way of making sure this project doesn't interfere with any of your other projects by installing third-party Python libraries in a place that only this project can see them. Okay, so let's create that project. It's creating a virtual environment for us. And it's really, we don't need the virtual environment for this first step, but it won't hurt to have it. Okay. I'll just ignore that. Okay, so what we'll do to make this easier, I'm going to download this file here. So I'll go to the raw version and save that into my project folder. And then I can refer to it inside the project, so it makes it a bit easier. Okay, so here it is here. And we can check what we're doing. Oh, let's put a txt on the end. Okay, let's rename that. Okay. And now in PyCharm, I can view this as a rendered markdown, or I can just view it as the raw text. So let's do rendered markdown. And you see in here, it gives us a play button, which means it'll automatically open a shell and run these commands. So if I do that, hello from Docker, it shows it's working correctly. Not sure why we didn't get everything there, but anyway, that's fine. Now you see, in these terminal, it starts with venv in parentheses, and that means we're running a virtual environment. So stuff that we're doing here is, if we add third-party libraries, it's not going to affect other problems. Now I'm on Windows here, so I'm going to type py-version to see which version of Python I'm running, and it's version 3.10.2. And so we just remember that for what we're going to do here. Now we're going to make a directory called bpaml183. In fact, we've already made that for this project, so that'll be there. And in here, we're just going to create a directory for this particular task. And you can see that directory is being created. And then we're going to go into that directory and we're going to create a file called hi from. So that's going to be a new Python file. And it's hi from. And in that Python file, it's just going to have these two lines. I can just click on copy there to copy it and paste. And there's my program. So if I save that, I can run this particular file. So I'll go up here in PyCharm, current file, and say run. And it says hi from Python 3.10.2, which is what we worked out before, is what the version of Python we are in. And if you're doing this from the terminal, you would do that by typing at the terminal. Let's change directory into task hi from py, and we'll just write py for Python. So on Windows you just write py. On Mac and Linux you'd write Python 3 to say that you want to run Python 3, and then the name of the Python script that we want to run, and there it goes, hi from py 3.10.2. Okay, so that's really the basics of how to run a Python program from the command line. Now what we're trying to do next is run it from a Docker container. And so we'll go over here. So what we need to do is create a Docker file in this directory. So it's got to be in task-py, and this may help Leo if this could be the problem if he hasn't got it in the right place. So we're going to create a new file. It's just a file this time, not a Python file. And you've got to spell it exactly right. So it's got to start with a capital D, and then the F has got to be lowercase, and it's got to be all one word and no suffix at the end. So just Docker file like that. And in that, we're going to put just this text here. So we're going to say we want to build a container which is based on, we're going to build it based on this image from Python 3.11. Inside the container we're going to create a folder from the root directory called /bpaml183, and we're going to copy our current directory, which is that dot there, means current directory, into the root directory in our container. And then when we run the container, it's going to run Python, is going to be the name of the command, which is like I just ran py in Windows, Python 3 on Mac or Linux. In this case it's just Python because it's the only Python in this container is Python 3, and it's going to run the script hi from py, which we're going to copy from our current directory into the container. So let's save that and go to the next step. We've created the Docker file. It just explains all those parts to it. And now we're going to build an image. So we're going to build our image, and then we're going to run that image. So you see Docker build, we're going to give the image a name, so -t to give it a tag. It's going to be called bpaml183-pi image, and it's going to be based on the Docker file that's in the current directory. That's what that dot means there. Okay, so I'm in the right directory down here, so I'll paste that in. Now, I don't have Python 3.11 image downloaded, so it's going to do that now for me, and any prerequisites that Python 3.1 needs to actually build up the image. So each of these images is built on a previous image, so Python 3.11 will be built on another image, which will be built on another image, and so it downloads all of those, and so each time it builds on it, it's just building the difference between it and the previous image, so it really reduces the amount that has to be downloaded, which is good because we're actually creating a whole computer with an operating system and software installed, and we don't want to take too long to download. And if we look in Docker Desktop, we can see in our images here that we'll get an image created that will be called the bpaml183, etc. So let's go back and see how it's going. It gives us progress. Alright, it's created the image. Let's go here, and there's the image. We can see that we're looking in images here, and Docker Desktop says that image has now been created. Now that it's been created, we can run a container based on that image. And it says hi from Python 3.11.3, and then it finishes the container. Okay, so Leo, I've just managed to do it following the instructions exactly as they are here. So can you see anything that I've done differently to what you did? Now, for your reference, I've just given you some more Docker commands here. But I think that's probably enough on Docker, except we're just going to use it to get rabbitmq running. Okay, so let's create the rabbitmq project. We're going to create a virtual environment, which we've already done. Mine's called venv. Here I suggested calling it venv183, just to make it a bit clearer which of these is the module name and which is the virtual environment name. Then you have to activate it. So if you're on Mac or Linux, that's how you activate it. On Windows, you can activate it. Oh, no, you don't want source there. You just want to go. So get rid of source and just type that venv183 scripts activate.bat. Once it's been activated, then I'm going to create a requirements.txt file so I can keep a track of all the third-party libraries that I've added. So let's do that. So I'll create a new file, requirements.txt, and in that file we just put the name of the one third-party library that we need, which is Pika. And you can see how PyCharm recognizes that requirements.txt is going to say which third-party libraries are required, and it's saying we don't have that one yet, so do you want it installed? So if I click install requirement, that will install it for me. I can click ignore extension because I think PyCharm handles requirements.txt quite well. And down here it says it's successfully installed Pika. Alright, so if I'm on the command line down here, I can just say pip list, and it'll tell me all the third-party libraries that are installed, and you can see I've got Pika as well as pip itself, which is what we need to run the pip command, setup tools and wheel. and it's telling me the new version of pip is available if I want to upgrade that, which I normally would, but let's just keep working here. Okay, and now we want to run rabbitmq. So we've got some software which will handle all the messages that we're going to be sending from our Python programs. So if you look at this website here, it'll say you can use Docker to run it, and here's the command to run Docker. So let's just run that. And that's just going to use an image that's on the central repository, so we don't need to have a Docker file to do this one. Now you see here in that command it's got --rm, which is basically says when you're finished with a container, just delete it, just remove it. And I actually normally put rm. I actually use that normally when I run Docker images, actually create containers, so that I don't keep getting a whole bunch of containers building up here, as you can see that I am already. So I'm just going to delete those two that I don't need. And we just keep the one called rabbitmq that we named with -t, rabbitmq, and it's currently running, and it will just keep running until we finish it. So we can stop it by either clicking stop here in Docker Desktop, or we can go down here and type Control-C. All right, now while this Docker container is running, we can look at the logs. I mean, we can see the logs that have come out here in it, but if you were somewhere else, you can, in fact, I can just press play on that and it'll start a new shell and run that command, and there's the logs. So I'm doing that, I'm inquiring on an existing running container just to give me the logs that have come out of it. And there's a whole bunch of other things you can do with containers. Right, download these tutorials and put them into the project folder. So our project folder is bpml183. So let's go and grab them and stick them into this folder. So I'm going to go back to my browser. And we're going to have one for sending messages and one for receiving messages. And these are just straight off the rabbitmq tutorials. So that's a short little program that will just create a queue called hello and send a message called hello world. So let's save that. And it's already in the right plot. Send as type. I think that's right. And let's try this one. More tools, save page as receive.py. So there's our two files. There's our send and there's our receive. So even if you're not wanting to actually send messages, we're going over a lot of useful procedures and techniques for handling Python files and running programs and running an IDE. If you haven't got the IDE installed, let me know, and if you want, tell me what you've got, and I can try doing it from a command line, the same sort of thing, so you can see what's needed to be done. Okay. So what we're going to do, we've got our Docker image running, so it means we can run our file. So we've got receive, and it's going to connect on the default port, which is 5672, which is the one that the Docker image is listening on. So we don't need to specify a port here. And it's just ready to receive anything. So if I run that, it'll just sit there waiting for messages. And see, it says here to exit, press Control-C. So that's That's just in a loop at the end here, running main, and main just runs this here and does this consume all the messages, and then to start consuming will just keep going forever until it gets a keyboard interrupt, something like Control-C, where I've noticed that Control-C doesn't always work on Windows, but I've found Control-F2 seems to be working at other times. Alright, so there's our receiver. Now let's run our sender, and the sender is going to send hello world. So let's run that. It's sent hello world. Let's go back to the receiver. You can see the two tabs here. This is what send, and it's now finished. Receive is still running because I've got a stop button, and it's received this hello world message. So let's go back to send and send it again. I'll send it 2 more times, and we'll go back to receive. And you see it just keeps receiving hello world, hello world. So what's happening? Send is publishing to our rabbitmq, which is running in our container. rabbitmq is storing it in a queue, waiting for something to actually consume those messages. And there is something, and it's our receive program is there saying it's going to consume those messages. And because it's there sitting there waiting, pretty much as soon as they go in to rabbitmq, they come straight out, and they get consumed by this program. All right, now we can, send is already finished, but receive is still going, so let's quit it. So see if you can work out a way of quitting it. If you're running PyCharm, just clicking on this red dot, red square here is a good way of stopping it. So I'll click that. It just says interrupted and finishes. Right, now rabbitmq, that should be not rabbitmq, not rabbitmw, has a management console. So let's go and have a look at what that looks like. So it's on a different port, 15672. And so we'll open that in a new tab. Here it is. It's already logged me in because I logged into it before. But if you're running this on your computer, the username is guest and the password is guest. So I'll just do that. So GUEST. And remember, this is just some software running on a container, and the container is going to be deleted when it finishes. So there's no point in changing the password because that'll all get deleted. So we can see here in our list of queues that it's created a queue called hello, and we've had some messages coming in and out of that. Let's see, in exchanges. So if you want to understand a bit more about this, the rabbitmq's got some really good documentation on what exchanges are and what. So I'm going to go. Let's see. Let's go to the rabbitmq site. And we'll just have a look at the overview. Let's find it. So this is how our Hello World program worked. We've got a publisher that sends a message. This is rabbitmq, which is the broker. We send it to an exchange. The exchange works out where it's going to put it. It's going to put it in a queue, and then it's going to wait in that queue until a consumer consumes it, and then it's going to go out of the queue and get deleted. But it'll stay in that queue until it gets deleted. So that's what's called a direct exchange, and you can even say when you're going to a direct exchange, you can give it different routing keys, and that will work out which queues to put things into, and then you can connect each of the consumers to a particular queue, and they'll get everything that's in that queue. So that was a direct one. You can also get a fan out one, which will go just to every queue that's connected to that exchange. and there's topics. But anyway, there's subtle differences between all of these ways of doing it, and if I explain them to you, you're not going to understand it, so I'll just leave it at that. Okay, so we've logged into the management protocol. Now we're going to let's send some more messages to the queue. And remember, this time we haven't got a consumer connected. So let's have a look and see what happens. So there's our overview of our rabbitmq broker, and then over here we'll find our send program, and let's send some messages. So I'll send one message, and so it's sent hello world, and you can see here there's a message being sent in the last minute. Let's send another one. Let's send about 4. Okay, so we've got these messages coming in, and they're getting queued, and the queue is just getting longer and longer, and it's up to four different messages in the queue, and that's because we haven't got anything taking anything out of that queue. So let's run our receive program, and that'll pull the messages out of the queue, and then they'll get deleted out of the queue. So we can see we've got 4 messages in the queue here. We've run receive. It's received all those 4 messages. We can see here there's been a bit of a message rate, quickly taking them out of the queue, and now the queue's gone back down to 0. Okay, so this is demonstrates synchronous messaging using Pika's blocking connection. So synchronous is the most easy one to understand. So we've created a blocking connection, which means it just goes through and does the things one at a time, and the program will just wait until each step is finished before it goes on to the next one. Okay, so now we're going to create a modified Python program called sendMessage to be able to send any message attached as a command line argument. So let's copy all this code here. I'll click on the copy icon there. We'll go into our project and say we want a new Python file, and we'll call it sendMessage. And it's a Python file, and we can just paste our code in there. And what this is going to do is pretty much the same as the last send program, except when it works out what the message is going to be, it's going to be either hello world, or if we type something in on the command line, it'll use that as the message instead of hello world. And it's going to send it to the same. So the routing key is to work out which queue it's going to go on to, and it's going to tell us that it's sent that message. All right, so that's good. We'll go back to the instructions here. So let's have 2 receivers running simultaneously this time in separate shells. Okay, so we've got one receive running here. I'm going to stop that one. I'm also going to create a new view mode. I'm going to split it and show on the right. So let's see. So send, I can finish with that one. Oh, I know what I'm going to do. I'm going to do it from terminal. So I'm going to say split right and split right again. Okay. So we're going to have 3 programs running. We're going to have 2 receivers, and one sender this time. So I'll just clear the screen there, clear the screen there, and clear the screen there. So these are terminals. We've also got the run tabs here, which I'm going to stop those ones, and we'll do it all in terminal this time. So we want Python receive.py to run that twice in our terminal. So let's run it here. So that's one of the receives, and there's another one. So they're both waiting for messages, and then we're going to run lots of sends in this one. So we'll copy all of those and paste them into here. And so you can see that we've sent 7 messages in, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and our 2 receivers have received them alternately. So one received the 1st message, then the 2nd message, then the 3rd message, then the 4th message, the 5th, the 6th, and the 7th. All right, but it all happened very quickly. So let's have a look at what would happen if some of these messages took a lot longer time to process than the others. And so what we can do here, we can count the number of dots in each message, and we'll take 1 second for each dot that's there. So we'll add that into receive.py in our callback. So this is the data coming in, and then it's going to wait for that many seconds and then say done. Okay, so remember here we're going to try to quit these, so we could try Control C, and that worked in that case, so that's good. And Control C, stop this one, so that's stopped, and this one was already stopped because it was a sender. So we'll just use CLS to clear all our screens. And now we're going to run our new receive.py, Python receive.py, waiting for messages. And remember, this time it's going to take a bit longer to process the ones that have got lots of dots in them. And there's our 7 messages, and you see some have got lots of dots and some have got a few dots. Okay, so these ones here, the even ones, it's all processed pretty quickly, but meanwhile this one here is taking a long time because it's getting all the long messages. So I've deliberately made the odd ones quite long and the even ones quite short. So it shows that it's not really a fair distribution of these tasks, because one of the receivers was getting all the quick ones and one was getting all the long ones. So what can we do about that? And the way it's done is we do manual acknowledgement. So each of these receivers has to acknowledge when it's received and processed the message. So that way our rabbitmq broker has got an idea that one of them is being held up quite a lot longer than the other. So what we'll do, we'll add one line to the end of receive.py callback function to provide the manual acknowledgement. And actually manual is the default because it's more typically what you would want. But we set it to auto before so that we could demonstrate this issue. So receive. Okay. We'll quit these. So remember how we quit these, and we'll clear the screens. Okay, then we'll run our receivers, this time with some acknowledgements happening. I'll just check. Yes, we should have changed auto acknowledgement to false. So in our receiver, see we've got it here for true, we'll set that to false. We'll send out 7 messages. Once again, nothing's visibly changed. We're still getting the quick ones going to one receiver and the slow ones all going to the other. So it says here, not much has visibly changed. However, we can now add one more line to basic consume and just say that we only want each consumer to prefetch one message at a time, and so that then it's not going to take a message if it hasn't finished with the previous one. So we want to put this line before basic consume to tell rabbitmq that workers should not prefetch more than one. So that's in the receiver, basic consume, and prefetch count equals 1. And let's do the same experiment this time and see how it goes. So now we can see that this one was getting now that well, just the odds and the evens are getting mixed up because each one's not taking a message until it's finished with the other one. So second message finished before first message, so it was able to take third message, which meant that it wasn't available for taking fourth message. So this one took fourth message, which was quite quick. So it could then take fifth message before this one took sixth message. Once again, quite quick. So fifth message was still being processed here. So this one took seventh message. All right, well that's actually the end of all our experiments we're going to do, but I've given you some links here to some other examples. So worker.py, we've actually been, this is the second tutorial in the rabbitmq tutorials called worker.py and newcast.py, and what this is doing, as well as what we've just demonstrated, which was how to get your queues to only take a message if they're not busy doing something else. This one also shows the concept of making messages durable, so we can guarantee that the message is going to get through. And not get lost. So often you can have network outages, you can have equipment shutdowns, and with durable messages, they should the messages should persist, and you can set the durability at all 3 stages of the message transmission. You can set it on the exchange, can be a durable exchange. So if it's coming through the exchange, hasn't gone into a queue yet, but if the exchange is durable, then the message will be saved and will still be there if you restart rabbitmq, where we're actually because we're doing it in a container that gets deleted each time, it won't be saved. But if we wanted it to be saved, then we would have to create a volume for that container for it to save those messages. Then the queue itself can be durable. So you've got the exchange can be durable, the queue can be durable, and then each of the messages can be persistent. So in this case, we're saying persistent delivery mode, that's for the message, and in our queue declare, we're saying durable equals true. And so that means that the queue will be durable. And we're using a default exchange, and the default exchange has already got the feature of being durable. So you can see there it says durable : true. Now Pika is got some other examples on their site. Shows you how to do asynchronous communications, and that's asynchronous will give you better performance because the code won't be sitting there waiting for messages, waiting to receive messages, or waiting to send messages. It'll do that asynchronously, so it can be doing other things while it's waiting for those messages to be sent or received, and so you'll get overall better performance out of your software. It's just a bit harder to write the code that does that, and the way that you achieve that is you use callbacks. So for example, when we connect, we use a select connection rather than a blocking connection, and we say when the connection is open, then call me back on this function. And if there happened to be an error while it was opening, then call me back on this function. And when it finally closes, call me back on that function. And then you have to define those functions. So there's the on connection open, and you can say in that case that I'm just going to call my own open channel method, which is down here. And you see when I call the open channel method, it says call me back once the channel is open. So we had the connection being opened here, and then we got the channel being opened, and an on open for that, and there's a on channel close callback and the channel close. So these are all callbacks, and that's just how you have to set up your whole program. So it's a little bit more difficult to understand how they work, but you can then make sure that everything gets covered and your whole program is not being held up by slow networks or full queues or things like that. Let's go back. Okay, so that's it for this week. Didn't get a lot of questions. I didn't see any in the live chat. And Leo's been quiet once the session started. So I hope he managed to get his bit working. Next week, the session will be taken by Arun. It'll be online, and he'll be dealing with a machine learning topic. The following week will be the first week of June, and so on the first week of every month, we try to cater more for absolute beginners. So you can, if you're new to Python, that's a good session to come along to, and you can ask any questions you like. I mean, you can ask any questions any week, but we'll certainly have more time for going into detail about those beginner issues, like how do you install Python, or how do you get the indenting right, or just anything as basic as can be. They're all fair questions. Well, thanks for coming along. I hope you liked the video. You could leave comments, say anything else, any particular topics that you are interested in. You can put those topics, comments into Learning to Code on Slack or on the comments below the YouTube videos. And I hope to talk to you again in a couple of weeks' time.